Hi there, my name is Andrew Brown, and welcome to Structural Isomers. This video will be a little on the short side because all we have to review is the defining properties of structural isomers and how they differ from stereoisomers. After watching this video, you should be able to answer questions like this one, which is asking you to identify the compound that is not a structural isomer out of those given. Structural isomers, which are also sometimes referred to as constitutional isomers, are one of the most basic classes of isomers. They have the same molecular formula, but differ in how their atoms are connected. For example, 1-propanol is a structural isomer of C3H7OH, meaning there are other possible compounds with that same formula, such as 2-propanol. While 1 and 2-propanol both have the same molecular mass, their differing connectivity means that they will also exhibit different chemical and physical properties. Now that you know what structural isomers are, we should point out what they are not. Take, for example, 2-bromobutane with its molecular formula C4H9Br. If you move the bromine group over one carbon, you can create the structural or constitutional isomer 1-bromobutane. Now, you've probably heard of other isomers like enantiomers and diastereomers before. Those are just a couple examples of stereoisomers, compounds whose atoms are linked in the same order, yet differ in spatial arrangement. Oftentimes this is because of stereocenters. Take a look at the two examples of 2-bromobutane on the screen here. We say they are stereoisomers because of the reversal of the stereocenter. Drawing a circle from the lowest to highest priority substituents in each example produces a clockwise pattern, indicative of R stereochemistry, at least in the compound on the right. While stereoisomers are ultimately much more interesting and higher yield for the MCAT than structural isomers, this level of basic definition and contrast between the two is all we'll cover in this video. Although the top 3 priority substituents are in the same order in the two representations of 2-bromobutane, for now, just note that moving the lowest priority hydrogen from the back to the front of the molecule has flipped the stereochemistry. Okay, so that actually concludes the material this video will review. Now, apply what you've learned on a practice question. This one is asking you to examine several given molecules and pick out the one that is not a constitutional isomer of 3-methyloctan-1-ol. The answer should be A. The most straightforward way to approach this question is to first identify 3-methyloctan-1-ol's molecular formula, C9H19OH. A quick scan of the answer choices confirms that they all have the correct formula, so now let's draw out the molecule. Starting with the 8-carbon base chain and adding in the hydroxyl and methyl groups at the 1 and 3 positions, respectively, yields this molecule. Look familiar? Notice it's exactly the same as A, and so A cannot be a constitutional isomer, therefore A is our answer. Alrighty, we're almost done, so let's now review the main points covered in this video. If you remember hardly anything from this video, make sure to at least be aware of the definition of a structural isomer. These example molecules that we presented, 1 and 2-propanol, show it best. Same molecular formula, different connectivity of atoms. Thanks very much for watching, and good luck in your continued MCAT study.